Hi everyone, this is Fahaz Mirza and I welcome you to the channel. If you are a regular follower of my channel, you know that I cover speech to text, speech to speech models quite frequently. Recently, we covered a model called as Moshi from Kyotai and we found out that that was one heck of a model when it comes to quality. The same company Kyotai has released this streaming speech to speech model called as Hibiki 1 billion. It also comes in 2 billion and few other variants. In this video we are going to install it in our Google Colab for free and then we will test it out how it works. You can use the same instructions to get it installed locally. Either you can launch it in your Jupyter notebook, or you could just throw all the code in your Python file and run it. I will also give you the link to this notebook and you can easily run it from anywhere you like. We will be also using the free GPU with it. Kyotai, the company, has a very interesting history with the names. For example, this Kyotai company's name mean art in Japanese and it refers to human form or figurative sculptures. And that is why when I saw this name Hibiki for their speech model, I searched for it and it turns out that Hibiki is a Japanese word that has multiple meanings, but especially it refers to sound or echo. It refers to the reverberation or resonance of a sound, to be specific. And in a more poetic sense, Hibiki can also mean harmony or resonance, which implies a balance or synchrony between different elements. So that is quite interesting in naming for a speech to speech model. You can also use it for speech to text. And if you don't want to do streaming, that's fine. You can simply use it for an offline version. So before we start installing it, let's have a very quick look as what exactly this model. So as I said, Hibiki or Hibikai, my apologies if I'm not pronouncing this Japanese word correct. It is a model for streaming speech translation, which is also called as simultaneous translation. And unlike offline translation, where one waits for the end of the source utterance to start translating, this Hibiki adapts its flow to accumulate just enough context to produce a correct translation in real time, chunk by chunk, as you can see on your screen. So as the user speaks, Hibiki generates natural speech in the target language, optionally with a voice transfer along with a text translation. Right now it only supports French to English translation, but these are very early days, so hopefully it is going to improve a lot. And I'm more than sure that the way Qt has been performing for the last few months, I have no doubt in my mind that it is going to expand further to other languages. Okay, also you can run it on your edge devices, on your mobile devices, because the footprint is very low. So let's try to get it installed and then we will see how it works. So let me introduce you to the sponsors of the video, who are AgentPod. AgentPod lets you efficiently deploy a personalized knowledge bot across platforms like Discord, Slack, and others. It is ideal for open source tech communities and startups that provide user support, and I will drop the link to their website in a video's description. Okay, so now let me take you to my Google Colab. First thing, just click on runtime and then change runtime type. Select your free GPU from Google, and then we can install first the prerequisites. In the first cell, you can see that we are installing the Moshe's GitHub repo. Don't worry, I'm going to drop the link to it in video's description. So it is installing radio. It is also installing all these prerequisites. So let's wait for it. Okay, so everything is installed. Let me first show you an offline translation. So we will provide it an audio file in French, and then we are asking it to translate it into English because that is what is supported by it. If you look at this command, all we are doing, we are providing it the model. We already have downloaded the audio file, this grapes.mp3 here in the first cell. And if you click on this folder icon, you will see that it is already present, and I will also play it shortly. So, and then you can see that it is using this batch size. The batch size controls the number of parallel translations over the same files, and then we are setting the classifier guidance coefficient to 1, and that can increase speaker similarity, although large values will lead to artifacts. So I'm not just going to keep it as is. uh, Let me run it. It is going to produce. While it produces it, let me quickly play the file, the source file in French for you.
Bonjour, aujourd'hui, nous allons préparer des crêpes. Pour cela, il vous faudra de la farine, des œufs, du lait, une pincée de sel, du sucre et du beurre. Pour commencer, mettez la farine dans un saladier avec le sel et le sucre. Faites un puits au milieu et versez-y les œufs. Commencez à mélanger doucement. Quand le mélange devient épais,
So it's a minute long audio, so I'm not going to play the whole of it. So this is what it is going to do it. So you see that it is downloading the model. The size of model is around 3.6 gig, so it should fit onto this D4 GPU easily. And then it is going to uh, do the translation from French to English, and then we will play it out. So let's wait for it to finish. It is almost there. Let's also have a very quick look at its architecture a bit. So as I mentioned earlier, it is based on Moshi. Moshi, if you remember, which we covered in this video, was a speech text foundation model that is also powering this, and that enables real-time spoken dialogue. And the main architectural components here are a bespoke text language model backbone, and then a neural audio codec with residual vector quantization, and with semantic knowledge distilled from a self-supervised speech model. The streaming, the hierarchical generation of semantic and isostic tokens for both the user and Moshi, along with time-aligned text token for Moshi when using Einer monologue, as you can see in this diagram. So this is a bit of a technical side of things. If you are interested in learning more, they also have shared a paper, by the way, if you're interested, in order to check it out. So there you go. It has downloaded the model, and then it is going to do the translation. There you go. So this is what it is producing. And if you're a French speaker, please also confirm if this is correct. Looks good to me, by the way. And the speed is not bad, running out on free GPU. It's a minute long one. Looks pretty cool to me. So there you go. It is writing the now audio in English. Hopefully it is going to display. So let me run it in the English one.
Today, we're going to make some pancakes. To do so, you need flour, eggs, milk, a pinch of salt, sugar, and butter. To begin with, put the flour in a bowl with salt and sugar. Make a well in the middle and pour the eggs. Start mixing slowly. As the
Looks quite good with all the pauses and stuff. And this is a second.
Hello, today we will make pancakes. To do this, you will need flour, eggs, milk, tweezers of salt, sugar, and butter. To start, put the flour in a bowl with salt and sugar. Make a well in the middle and pour the eggs. Start mixing gently when the mixture becomes thick.
So I believe the first one is better, but second one is also not that bad. So it seems like a French accent. That is fine. So pretty good, I would say. It just took around 47 seconds, and then around 1 minute mark, it has completed the whole translation quite easily. And also for the streaming one, they also have shared this Gradio demo. Let me run it. So I'm just running it with Gradio. As you can see, it established the Gradio tunnel, and it should produce a link. So let's wait for it. It is retrieving the checkpoint, loading it. I'll just cancel it. So let's wait for it. And there you go, it has loaded and warmed up the model, and this is a Gradio link which we can open in our browser. Let me open it. And this is how it looks like in Gradio. And let me click on connect here. It is asking me to allow. Bonjour. It is. Now I have just done one word and it is taking long time to produce any meaningful result. And if I go back to my Google Colab, you will see that it is doing something. You see, it is just running and handling the frames. So it seems it takes long time in order to produce that, and that is not really a streaming, I would say. So this is the one which we created. Yeah, you see, it's still nothing. So even if I disconnect, it doesn't really do much. I'll say start over, thinks and speaks at the same time, and listen and can talk. It's not doing anything, and it is running in the Creative one. So anyway, I think I will stop waiting for further, but I'll keep it transparent. I'm not going to edit or anything. I'll just show you as is. Now, I believe pretty good for the offline, but for streaming, they need to improve it. I have also tested it on my local system, still the same result. It eventually comes back with the English one, but takes long time, like 10 minutes for few words, which is not really good enough. I think they need to improve it. And same is that go with the 2 billion one. It comes in 2 billion size too. So I believe that needs to be improved. Plus, they also need to include more languages. Anyway, let me know what do you think. If you have any success in terms of streaming with this model, keen to know about your experience. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps. Thank you for watching.